Hello, my name is McKenna Dedrick, and today I am going to be talking about IBM SPSS. So today we're going to talk about what SPSS is, how to download it. We're going to talk about what a t-test is and how to perform a t-test using SPSS. How to run the SPSS program when performing a t-test, and also how to interpret the results from a t-test that is ran in SPSS. So let's go ahead and get started on what SPSS is. So SPSS stands for Statistical Package for Social Sciences. And SPSS was first launched in 1968, and then later in 2009, it was acquired by IBM. So, the way this program was started was actually because of the behavioral sciences field. So, behavioral sciences, such as psychology, really wanted a program that would allow them to compare and contrast their similarities that were occurring in their fields. So that is how it got started. Today, the SPSS program is used a lot more widely outside of behavioral sciences. It is being used in the corporate world, in data mining, for marketing teams, and also for researchers. So let's go ahead and talk about what the SPSS program actually looks like. So SPSS has two main views that we will be dealing with. The first one will be the data view. Now, this is going to look extremely similar to Microsoft Excel, where you're putting in data in rows and columns. So, for the data view, the rows are used to represent each case, and the columns are used to represent individual variables. The next view that you'll see is the variable view. This will display the metadata, and this will pretty much be more information on the data values being used. So it will give you different options on how you want to set up and group your data. I like to think of it as almost like a settings behind your data. So you kind of get to customize how you want your data represented. For example, how many decimal points, the type of data, if it's an integer or a string, and also then how you want that data grouped. So now we are going to talk about t-tests. So the t-test was first developed in 1908 by William Seeley Gossett. And the purpose of t-tests is really just to compare two fields. And you do this by evaluating the means of samples. Um, with t-tests, the max amount of samples you can have is 2. You cannot perform a t-test on 3 samples or 4 samples. So there are 3 types of t-tests as listed. There is the 1 sample t-test, the 2 sample t-test, and the paired t-test. And so on the right here, this is how to calculate a 2 sample t-test. So as you can see on the right, we are going to take the average of both groups separately and subtract them on the numerator. That's going to be the x's up top. And we're going to take the absolute value of this number to get the difference between the group means, and that is going to be our numerator. So next we're going to calculate the variability of the groups, and we are going to do this by taking the square root using the standard deviations, as you can see by the S, and the number of members in a data set, as you can see by the N. And so this formula really just calculates the t-value. When performing a t-test, there are more calculations and results that come out of the t-test, but just to give you an idea of what it looks like. So, as I previously mentioned, the main reason to perform a t-test is to compare two groups. However, there are a few other reasons why you would use a t-test. The first one being effectiveness in research. So, t-tests can be used to evaluate the effectiveness of a treatment, just like if a new drug reduces symptoms more than a placebo would. A t-test is helpful in answering that. The next reason is to test small sample sizes. Um, T-tests are really useful when the sample sizes are smaller. I believe it's typically under 35 in a sample size that you would want to use a t-test. For larger sample sizes, there are other test options. And then the next one is evidence based decision making. T-tests are effective to make an informed decision. Rather than assumptions or guessing, the t-test offers evidence-based differences to make a decision in that matter. So now that we understand what a t-test is and what SPSS is, I'm going to show you how to download IBM's SPSS program. Here on the screen, you can see the steps to do this. I am also going to show you a walkthrough of how I downloaded it. So you're going to click on that link up top. As you can see, there is that link on the top of my screen. And this is what the IBM SPSS homepage looks like. You have two options. There's the paid version on the left and the free version on the right. The rest of this page really just talks about what IBM SPSS is, more of a selling point for customers, just to give the customer an understanding of what it is. So we are going to click on the free version right there, and it's going to bring you to a new page, and this is going to be your registration page. So you will get a 14-day free trial. Otherwise, the paid version, you would have to obviously pay for it. So we're going to do the 14-day free trial. And we're just going to put all of our information that it requires in the required lines. So as you can see, it's asking for a little bit of information on there. And then once you enter in that information, you will click next. And then it's going to ask you to verify your email. And then once your email is verified, you will have the IBM SPSS in your products page. So next, I am going to go to my products page just to give you an idea. Okay, so now that we have landed on the products page, as you can see, I only have one product here, and that is going to be the IBM SPSS trial. And then this is just the IBM products page just to give you an idea. So it's going to be in your profile. So you're going to want to click that blue download button there in the bottom left, and it's going to take you to the downloads page. And this will really just give you an idea of more about SPSS and also how to download it. So, depending on your operating system, there are different ways of download. This is just giving you an overview of SPSS. And then, as you can see, there is the Windows download at the top there. And then that bottom one is going to be the Mac download. For me personally, I am on the Mac operating system, so that is the one I downloaded. So once you get SPSS downloaded and all set up, we are now going to start with performing a t-test. And actually, before we get into performing the actual t-test, we need a data set to perform the t-test on. So here is just a data set I found online um, with group 1 and group 2. So as you can see, group 1 and group 2, just off assumptions, they do seem similar in values. The independent variable of the data sets are going to be the groups, so that's going to be group 1 and group 2. And then the dependent variable is going to be scores. The best way for me to interpret and understand this data is I like to think of them as test scores. So group 1 can be one class, and group 2 can be a different section of the same class. And group 1, that is how they performed on an exam, and that is how group 2 performed. So now that we have our data set for the t-test, let's talk about our hypotheses. So the null hypothesis states that there is no significant statistical difference between the two samples, and those samples are going to be group 1 and group 2. So that pretty much means that the means of the two groups will be equal, as you can see represented in the equation on the right. And the alternate hypothesis states that there is a significant statistical difference between the two samples, and that the means of the two groups are not equal, as represented in the equation on the left. And so in order to get our answer for which hypothesis will be correct, we will have to compare the critical value to the t-value. If the t-value is lower than the critical value, then we don't reject the null hypothesis. However, if it is greater than the t-value, or than the critical value, that means we fail to reject the null hypothesis. So now that we have our hypotheses, let's go ahead and get into the SPSS program. So when you first open the SPSS program, this is what you will see. This is the blank data editor, and as you can see at the bottom, we have our data view and our variable view. So the variable view is where you define the structure and properties of your data. Each row in this view represents a variable, and each column contains information about that variable. So some of the key columns that I went over here include the name. That's going to be the short name that is used to identify the variable. For example, score or age. Type is going to be whether the variable is numeric, string, or something else. The label is a longer, more descriptive name. Values is useful for categorical data. So, for example, you will use values to assign the group names. And then missing specifies if certain numbers should be treated as missing data. Measure defines the level of measurement, which can be nominal, ordinal, or scale. For our case, we will be using scale. And then the decimals and width, those control the appearance of the data. So I just updated it to scale, and then I'm going to click on the values, and I'm going to add our groups. So for value, I'm going to put 1 for group 1, and then I'm just going to label that group 1, and then I'm going to repeat that for group 2. And once I have those added in, we will hit OK. And then from there, we are going to add scores. And as you can see, just like it did with groups, it autofills those columns for you. We're going to make sure that that measurement is on scale. Looks like I had a little bit of issue here. Here we go. And then everything else looks good. So we're going to go back to our data view. And as you can see on the data view, we now have groups and scores. And then also at the top here, you can see there's some options for handling and dealing with the data. And if you go to the variable view, there's a few more options of what you can do with the data. So we have these and they are all empty. So I am going to start inputting group 1 and 2 and the scores. So I already know that the first 10 groups are all going to be 1, and then the next 10 groups are all going to be 2, since we have 10 scores for each group. And so I'm going ahead and just inputting group 1. So now I am inputting group 2 on here. And for the sake of readability, I just did it as group 1 in the first 10 and group 2 in the next 10. However, I could have alternated between group 1 and group 2 values, and the results would remain the same. So now that we have all of those values filled in, we are going to go to the top, and since I have a Mac, my view may look a little bit different than yours, but these are just some more options of how you can deal with the data. We are going to go to the Analyze tab here, and as you can see, there's a few different options. We're going to want to click on that Compare Means, and we are going to click on the Independent Samples t-test there, and it's going to pop up with a new window. So we're going to want to put our groups in the group variable and the scores in our test variable. We want to make sure that the group values are correct. It looks like it autofilled for us. And then we're going to put that in the test variable. We're going to click on options in the top right corner there. Make sure it's at a 95% confidence interval and make sure that looks correct, and then click continue, and we'll go ahead and click OK. And from there, a new window will pop up. So looking at what popped up here, we have our group statistics, which is just going to show statistics for group 1 and group 2. And then this also gives you the option to edit how the table looks. And the next table is going to be the independent samples test, and that's going to be more of the data and information that we are going to be interpreting. And then at the bottom there is going to be the independent samples effect sizes, which we will also take a look at, and then it also kind of explains what each of those mean. So now that we have performed our t-test, you can see all of the information, and you do also have the option to save it in that top corner. So let's go ahead and take a look at what some of these numbers mean. So looking at our group statistics, we have groups and mean standard deviation and standard error mean. So from this table, we see that both group 1 and group 2 had 10 participants each. That is going to be our N. And group 1 had a mean score of 49.69 with a standard deviation of 2.32, while group 2 had a slightly higher mean of 50.54 and a standard deviation of 1.92. And so, although there is a small difference in means, we will need to further analyze it to determine if the difference is statistically significant. So then, moving on to that bottom table there, the independent samples effect sizes, we have three different effect sizes that we're going to be looking at. So the first one is reported as 0.400, and this means that it's a small effect size, which suggests a small difference between group 1 and group 2, with group 2 performing slightly better. The next one is reported to be 0.383, which is very similar to that top one, and leads to that same conclusion. And then lastly, that bottom one, which only will use the standard deviation of group 2 as the denominator to calculate, that is going to be slightly larger than the top two at 0.443. And this all suggests the same thing, which is kind of what we can gather just by looking at the mean of group 1 and group 2 in the group statistics. So now we're going to look at the independent samples test. And as you can see, there are quite a few values up there on that table. We have the t-value, we have df, which refers to degrees of freedom. We have the one-sided p-value, the two-sided p-value, the mean difference, the standard error difference, and then the lower and upper 95% confidence interval of the difference. So we're really going to be focusing on the t-value, the degrees of freedom, and then also the two-sided p-value. So let's start with the t-value. That number is going to tell you how much the group differs in relation to the variation within the groups. So it is calculated by comparing the difference between the group means to the variability of the data. That is going to be the value of our first calculation that we did when we were talking about t-tests. And so what do t-values mean? A larger t-value will mean that the difference between the groups is more likely to be real, while a smaller t-value suggests the difference is less convincing and may just be random in variation. So df, which stands for degrees of freedom, that refers to the number of independent values that can vary in a statistical calculation. So here we have 18 values. And then the p-value, this is going to be the number we're really going to look at. So now moving on to the next slide, let's interpret these results. So we have those three values that I talked about, the t-value, the degrees of freedom, the one-sided p-value and the two-sided p-value. And to really interpret these results, we are going to focus on the two-sided p-value. As you can see, the two-sided p-value is at 0.382. And so when we look at this number, we want to compare it to the probability value. So this 0.382 value is greater than the 0.05 probability value. And this means that we fail to reject the null hypothesis. So we're going to go back and look at our hypotheses and talk about what this actually means. So, as you can see, we have our hypotheses up again, and just to run through them again, we have our null hypothesis, which states that there is no significant statistical difference between the two samples, and that the means of the two groups are equal. And the alternate hypothesis states that there is a significant statistical difference between the two samples, and that the means of the two groups are not equal. So, based on our results that we were looking at, which hypothesis do you think is correct? So, if you stated the null hypothesis is correct, you would be correct. Because of the lack of significant statistical difference between the p-values of the two samples, we therefore fail to reject the null hypothesis, meaning that it is correct.